Oh, really? Okay. So today what we're going to be going over is the experimental method. So on Monday we started talking about the scientific method, right? Is the process or procedure that we use to conduct an experiment. We're going to talk about the experimental method. This is going to be the procedure or the process and the way in which an experiment is carried out. Okay? So what we're going to do today is we're going to start with the experimental method. Then we're going to do identifying variables. So that way on Thursday and Friday, we can start to kind of figure out what kind of experiment we might want to conduct over the rest of the month. Okay. So I'm going to use my highlight tool to highlight some stuff as we read through. So just follow along as I read for you guys. So the experimental method or procedure is the process or way an experiment is carried out. So what we're going to be talking about is the way that you guys will be carrying out a experiment. So what it does is it describes the materials used in an investigation and how they are prepared and used in an experiment. An experimental method is written in a step-by-step fashion. So this is super important. We need to make sure that when we are writing about our projects, that we're giving a step-by-step explanation of what it is that we are doing. The steps of an experimental method are written in chronological order. The steps are clear, specific, and detailed so that someone else could easily replicate the experiment. So the key pieces here are that we're going to be writing step by step and in chronological order. And can you tell me why writing things in chronological order might be important? Exactly. So making one wrong step, somebody else is trying to recreate your experiment, they might do it totally incorrectly if things aren't written down chronologically. So we're gonna have. Mhm. Yeah, especially with things like cooking. Yeah, that's a great example. Cooking is another thing where we have to go step by step chronologically, right? So like with pizza, you don't just like have like dough and then you throw a bunch of stuff on the dough and stick it in the oven. You have to make the dough a specific way in a specific order, add the ingredients. And you have to like pre-cook your crust a little bit before you can put your toppings on in most cases, right? The order you put your toppings on are going to change how it tastes in some cases, right? So let's go ahead. We're going to look at our next paragraph. Nope. There are several features of a good experimental method. First, the method should be written in stepwise fashion. The number of test subjects required and the number of trials completed are stated. Additionally, the specific amount of substances or materials used, the tools needed, and measurements that need to be taken are stated as well. Lastly, the time needed to complete certain parts of the experiment are clearly defined. So this is all talking about things that we're going to need to be including inside of our kind of our written portion, right? So we need to write our steps. So the method should be written in a stepwise fashion, right? Things like the number of test subjects, also the number of trials, right? Well, yeah, it could be like that. Yeah, right. So you could also. So a great example of this I have last year was a kiddo did a gummy bear based lab. And so they had a bunch of different gummy bears. And because we were remote, they took a picture of each gummy bear. Each one was a different color and they numbered them different numbers, right? So test subject one was a red gummy bear, right? So then whatever they did to gummy bear one, then they recorded what happened to gummy bear one. Gummy bear two was a white gummy. So then they did the experiment with gummy bear one and recorded. So depending on the type of experiment you guys choose to do, you do one experiment over a long period of time, right? Or you might do one short experiment with multiple different test subjects, right? We're going to figure out what we're going to be choosing. Hold on. Look at you with your, is that the SCP? No. Okay. Additionally, we also want to make sure that we're talking about specific amounts of substances and materials, as well as the tools needed and measurements that need to be taken, right? Finally, we want to include the time needed to complete certain parts, right? So we want to make sure that all of these are written out very clearly. Finally, a good experiment is easily replicated. In order for the experiment to be duplicated, the steps of the experimental method must be written in a straightforward and concise but thorough way. The experimental method is also important because scientists need to understand how an investigation was conducted in order to judge the reliability of the experiment. Scientists want to know if the experiment was performed in a thoughtful way. The experimental method will reflect if it was carried out this way. So, what is the reasoning that we write our investigation out the way that we do? What do we want other people to be able to judge? Yeah, the big reason why we write out our investigations this way was because we want to see if the investigation was conducted reliably, right? What's up? So that like happens in like TV shows and like movies because it's like a funny gag, right? Like something explodes and like it's funny to see somebody be like, "Oh my god," right? That's a German term called Schadenfreude, which means I'm glad that this didn't happen to me and that it happened to you instead. So it's like feeling happy at somebody else's pain, right? When somebody slips and falls, our first reaction is to be like, ha ha ha, right? Because we're like, oh, thank God that didn't happen to me. So that's why that's like TV shows, movies, they'd have that. But in reality, that doesn't happen. Usually they know that something is going to explode or they're not sure. So there's other like safety precautions that are taken to make sure that nobody gets hurt, especially chemicals. What? The scientist has a lab coat that is designed to keep their clothes from being stained by the chemicals. Why are some like design not the sun? So So again, that has to do with like movie, television, and like costuming versus reality. So I don't have it at the moment, but my husband is becoming a nurse practitioner and he has a lab coat, right? They have to have one, like the white coats. The reason why you have a white coat is because if something gets on the white coat, you can take it off and you're protected. So it's a protective gear actually in movies and TV shows, right? they don't have to be protected because they're not actually working with dangerous chemicals. Another example, one of my friends is a microbiologist. She also has a white coat that gets buttoned up all the way when she's like working in the lab, and then she unbuttons it when she's like sitting and eating lunch or walking around the place. And the idea is that if she got something on herself, she would be able to take the jacket off that was contaminated and protect herself in that way. Mhm. Very cool. Awesome. Okay. So now that we have gone ahead and finished this little passage, let's go ahead and answer some of the questions. So, and looking back at the passage, if you need to, what is an experimental method? Yeah. So to answer this specific question, we can go back to our very first sentence because that defines experimental method. So, an experimental method or procedure. So, our answer is the process or way an experiment is carried out. So, when we go to write our answer, we're going to write an experimental method. And then, if we need to go back to check, we can. So we're going to write, is the process or way an experiment is carried out? So you can see while I was going through and reading, I highlighted some things that I thought were important. I didn't highlight the entire things, right? But we're going to see if these help when I go back. All right. How is an experimental method written? What do you think, Aunt? Yeah, specifically, it's written in a step by step fashion in chronological order. Look, I also highlighted both of those. So we're going to write an experimental method is written in a step by step so in a step by step manner in chronological order. I'm going to spell words correctly. Which word? Chronological. So chronological is I want to say it's the Greek root is chronos, which is time, right? Awesome. All right, Aunt. So our next question is, what are the features of a good experimental method? So let's go back to our text. And do you think maybe Miss Wolf highlighted those as well? All right. So you tell me what you think the correct answer is. So those are some things. Let's go back and check. So you had written in a stepwise fashion. What else do we want to include? The number of test subjects and trials. What else? We want to know how much of each material we used, what tools we needed, what measurements needed to be taken, and the time needed to complete, right? 7 different things. So I want you to go ahead and pick any 3 and write those down as your answer. But you see, as I was reading. Can you put those in chat? I'm going to take a little document. Nope. You will, when we get to our experiment, I will have this as a document for you. Like you will be able to see all the different parts. So for right now, pick any 4 of the 7. I will leave it here so that you can go ahead and see it. Any 4. I'm going to sneak down now. I'm putting that the steps are written in a stepwise fashion. The number of subjects and trials is included. What's up? What's not working? Oh no. Oh, you're looking at the different versions. So see next to where it says today, 12:14 p.m. on the left top side. Up. Nope. Go up to the very top of your screen. Yeah. All the way to the left, there's a little arrow. Yeah, hit that arrow. There you go. Now, you're welcome. I don't know if Makai is actually here. Right. I know you're here and engaged. Yep. It's like. Mm-hmm. So I'm going to include tools and measurements needed as well. Then you can say measurements that need to be taken, right? That can be your 4th one. Yeah, what can we not figure out if that experiment is reliable, right? We don't say correct. Right. In science, we don't use correct and incorrect because it's experimental, right? We don't know what the outcome is going to be, so there is no correct or incorrect response. What we're concerned about is reliability. Is it done reliably so that if somebody needs to recreate it, they can, or also so that the results aren't manipulated, right? So, like, an example is if I put food dye in water, hot water versus cold water, it will dissolve faster in hot water, let's say, right? So but listen, because this is the important part about reliability, right? So if I don't use cold water, I only use hot water, are my results reliable? No, right? So we want to make sure that it's written correctly so that people can check to make sure that our work is reliable. You can go ahead and write that. Yeah. This is what at this point in middle school you should be doing at bare minimum for every single question you answer. I know you guys hate it when I make you write in complete sentences, but this is what your answer should always look like. Always. You can make them bigger if you have to. Mm. When we have finished everything we have to do today as a group, yes. All right, so for the last part, question 5, you're going to answer this on your own. I'm going to give you a couple of minutes to write out. So you're going to write an example of an experimental method for how to prepare a sandwich. Identify materials and tools you'll need and how much of the materials you need. Write the steps you must take to make the sandwich in a step-by-step fashion. Mm-hmm. Mm-hmm. So go ahead. You can choose any sandwich you want. Obviously, one of the easier ones would be like a peanut butter and jelly sandwich, right? So what I'm going to do is I'm going to set you a 5-minute timer. Answer this. Okay. When you come back, I'll set my timer up. Makai, if you are participating, you also have this 5 minutes. Again, I don't know if you're actually here because you're not answering when I try to get you. So it would be nice to hear from you or see your face. What we're going to do now is we're going to go over the second half. So we just finished up the experimental method, right? So that's the process in which you I'm sorry, my brain died. It is the process or way an experiment is carried out. And that's kind of like what we're going to write as our science log. So that's going to be what you guys write at the end after you have conducted your experiment, right? What we're going to do now is we're going to identify variables. So it's really important. Remember, we talked about variables when we talked about the scientific method. Variables are factors within our experiment, right? And we change how many of those variables for our experiment. Who remembers? How many variables when we conduct an experiment? How many? One. We only change one variable, right? So we need to be able to identify all of the variables in our experiment so we know which one we want to control. Go ahead. Just like with the last one, we're going to go through and read this. As we're reading this, I'm going to go ahead and highlight. So, and I know that you watched me highlight through the first one. This time I want you guys to pay closer attention to what I'm highlighting. What we're going to be working on, for this is when we're looking at, or for the remainder of the year rather, is when we're looking at text, how do we highlight the important information? Like, how do we figure out the important information that we're going to need to use later on? Okay. All right. So let's go ahead and we're going to read identifying variables. So variables are factors in a controlled experiment that you change, measure, or keep constant. There are three types of variables in a controlled experiment: independent, dependent, and controlled. So how many types of variables in a controlled experiment? Correct. Yep. So I'm going to highlight this, but change the color. Okay. No. I would like this to be read. Okay. So now we're going to go back and we're going to read the second portion. The independent variable is the factor that you manipulate or change in the experiment, right? So the independent variable is one thing we're going to control. A change in the independent variable affects the experimental groups. There is only one independent variable in a controlled experiment so that you can observe or measure the changes due to only one factor. So the reason that there's only one independent variable, right, is so that we can observe or measure changes due to the one factor. Okay. Now let's look at the dependent variable. The dependent variable is the factor you measure in the experiment. So the dependent variable depends on the independent variable. What does it depend on? Yeah. So the dependent variable depends on the independent variable, right? It changes because of the independent variable, right? The dependent variable must be observable or measurable. So that I think is important. In most experiments, there's only one dependent variable. So if we're thinking about on Monday, we were using the fertilizer experiment as our example as we went through. The one dependent variable what we were looking at was the size of the flower in a plant. Sir? Okay. So in most, not in all, but in most. Our final variable is the controlled variables, and these are other factors in the experiment. There are multiple controlled variables in a controlled experiment. Controlled variables are kept the same or constant for all experimental groups. So kept the same or constant. I'm going to highlight that. Keeping controlled variables constant is very important in a controlled experiment. You want to make sure only the independent variable changes so that you know it's the specific factor that affects the experiment. Let's say that you're testing the effects of sunlight on plant growth. You alter the amount of sunlight for different experimental groups. You should keep the amount of water, the type of plant, the type of and temperature same for all of the experimental groups to make sure that you are testing only the effects of sunlight on plant growth, right? So the last key part of this is keeping the controlled variable constant is important because we want to make sure that only the independent variable changes. So we know the specific factors that are affecting our experiment. Okay? Questions on what we read? No? All right, let's go ahead to answer our questions. So when we scroll down, our first question asks us, what is a variable? Well, remember, I highlighted stuff, so I'm going to scroll back up and see if I highlighted. Did I highlight the definition of a variable? Yes. So variables are factors in a controlled experiment that you change, measure, or keep constant. So we can simplify that to say that variables are factors in an experiment. You don't have to go beyond that. Yeah, I hear you. So for question 2, it's going to ask us to define dependent, independent, and controlled variables. So this time around, I'm just going to scroll up to the passage and you guys are going to write your responses independently. So I've highlighted important things. So make sure that you're answering question 2 on your own. And we'll review once you guys are done. We're answering question 2, and I'm not giving you the answer for this. I want you guys to use what I highlighted to help you answer the question. So for question 2, we are defining dependent, independent, and controlled variables. So since you just, I'm going to give you like 2 minutes. I do. That's okay. I'm going to continue through. Don't know. but you just got to worry about answering your questions. Finish up with question 2. Well, remember, we're looking for independent variable, dependent, and controlled. You're just defining them. So what color did I define? What color did I use for definitions? Mm-hmm. Ms. Wolf, there was a method to my multicolored. I promise. Yes, for this one, I'm okay with that. It's just asking for a definition, not a full response. Super. All right, so for Samara and Makai, if you guys are still here, we're just gonna do number 3 together, and then you guys are gonna complete 4 and 5 on your own. So number 3 is asking us, what are the nope, I'm in the wrong one. Here we go. Number 3 is asking us, what is the relationship between an independent and dependent variable? So again, I'm going to scroll back up, and I have highlighted it there. So we can see that the relationship is that the dependent variable changes because of the independent variable. So what you would do is you're going to go down to question 3, and you're going to type that as a complete sentence. What we're going to do now is we only have about 5 minutes left in class. So I'm going to go ahead and end our meeting. You guys have to be finishing questions 3, 4, and 5 on your own and submitting it. Okay. So complete 3, 4, and 5. Samara, I will post this video as soon as I've finished uploading it to YouTube so that you can watch the first half of the lesson. Okay. All right. Any questions on what you guys have to do? No. All right, guys. That is everything then.